All right. Hope everybody has their coffee, their snacks. If you are highly engaged on social media, then this is really old news to you, 20 minutes old, that the GoAERO fly-off venue will be at NASA Ames, specifically Moffett Field, which is a fantastic venue. Not too much else to say about that. I'm going to be talking about a little bit more about what to expect at the fly-off. NASA Ames, Moffett Field, if you're not familiar, it's in Mountain View, California. It's in the San Francisco Bay Area. The close airports are San Francisco, Oakland, and San Jose. It's kind of in the South Bay Area. And specifically, if you look at the airport diagram on the right, that's the official FAA airport diagram. Use that when we're talking about the nomenclature describing where things are on the airfield itself. There's a whole different campus map of NASA Ames where some things might take place, but generally what we're looking at is the west ramp, where primarily the event space will be. That's where like your team paddock will be, where you'll be able to, think of it as like your pit area, where you will have a space when you're not flying. And then finally, this is a quick screenshot of a windrose that I built by just doing a web search for, historical windroses. This is, I believe, February 2025 for that airfield. That's the sort of thing that you can look up, and this is part of the strategy of the GoAERO competition, is designing for the expected conditions, and having the expected conditions not being 100% predictable is kind of part of what makes this a somewhat interesting competition, how much margin you want to add for your system. So looking at this keep that west ramp area in mind. If we zoom out on that, that west ramp is down here. And this is obviously tilted on its side. Remember that airport diagram, which was north up? If you look in the lower right corner, there's a little north arrow there. So we'll be trying to build the 3 mission courses on this airfield. So there will be not only your team paddock, but also other event things over on that west ramp area, including on at least one of the days, probably members of the public as spectators. And so when the information I want you to know is that when we're building out these courses and laying them out, we'll be keeping at least 500-foot boundaries between where people can be and where the flying will happen. Those will be hard flight boundaries. Excursions outside those flight boundaries will be considered, a serious safety issue and likely disqualifying from the competition. So we'll be laying that out with 500-foot boundaries to people and active spectators, and at least 100-foot boundaries to other things like buildings. So in general, what we are thinking with laying these out, so when we look at a mission course, we're thinking, hey, this is where we are expecting you to do your flying. We will try to add at least a couple 100 feet of additional boundaries on most sides of that for things like if you have to do a blocked landing and a go-around, or to do excursions where this is the space where you are allowed to fly, to those hard limits where going outside of that is considered an excursion event, a safety event. Also, the mission courses that we lay out, there will be at least 3 of them. They're going to all run independently. So as is mentioned in the rules, there will be multiple teams flying and in the air potentially at the same time. But keep this in mind when you are thinking about your command and control and radio links and things like this. The other thing to mention is that the rule book mentions things like keeping independent radio links and multiple teams flying at once. That is the rules for the competition. Because this is happening in the U.S. national airspace and at this specific event space, there will be additional rules and requirements for what you have to do beyond what's in the rulebook for the purposes of winning a prize for the competition. So keep that in mind. What's written in the rulebook is just is not sufficient to be able to fly there. There will be a lot more. Those independent courses, that independence includes being able to operate them independently on the schedule, not necessarily everybody go out, get set up, and fly at the same time. It's going to be while these people are doing this thing over here, you need to be able to taxi out along a certain route without ever going within their flying airspace and along the taxiways and routes here. So that could be a possibly lengthy path. The rules do specify you need to be able to move your system at least at a walking pace. If you are planning on walking, this could be a long walk, so keep that in mind. Right? It might be worth it to introduce powered dollies or something that you can tow with a vehicle or something like that. There will also be limits on the amount of personnel you have. So you can't just solve the problem by saying we're going to have a team of 16 people pulling on ropes to get our system out to where it needs to be. There are limits on personnel in the rules. The rules specify you need to be able to move your system around with only 2 people of the operating crew. So keep that in mind. Most of you are going to need to engineer some systems to be able to do that. In many cases, if you can reuse your ground transportation vehicle to do that, right? You have something already that has wheels and an engine, then that'll work really well. And then mission scheduling for the event. So this will be an event of 2 or 3 days, and you say, well, how will we know what time slot we need? Some teams are going to want to space out their attempts because they're going to only have one set of batteries that they're going to need to recharge in between. Other teams are going to prioritize early mornings with low winds. Most likely, since we are expecting and hoping to have to have basically enough teams that it will be a very tight schedule, we will likely be doing a draft system where there will be a system for doing an order where you would say, hey, in whatever your draft order is, you can come up and grab a time slot for a mission attempt and go through a cycle like that. Obviously, that'll be more fleshed out for the event, but just keep that in mind that it is likely that picking your time slot, there will be an element of strategy and tactics to that as well. So if you did not see the announcement that went out a couple of weeks ago, this event venue will likely afford us the ability to have a productivity course that is, instead of several laps on a short course, just a simple long out and back. This is a better simulation of ferrying things from A to B, and it also means that it also allows us for, at the end where the operations zone landing strip is, for that to be narrow. So it's quite possible that you might be asked to, maintain runway center line for the first quarter mile or something like that. A question?
Is that 2 miles in total, like 1 mile out, 1 mile back?
Correct. Yeah, it's about a mile. So yes, as I mentioned, you might have to keep it narrow. There might be some narrow spaces. We'll be aiming for at least 1,000-foot width at the end where you need to do a turn, hopefully a lot more than that. But as are stated in the rules, you need to expect that there will be limits on your space and doing tight turns. Yes, question?
There was a question on the forum about the size of the landing area. Is that the traditional size where your vehicle can pull up, or what are the dimensions on that blue area?
Yeah, so the blue area is 5 feet at one end, 30 feet at the other, and 100 feet long, and that's a 10-foot gutter around it for parking your ground transportation vehicle. So on this airfield, there's the California Air National Guard. In general, when this event is going on, there won't be other operations at the airfield. No Google private jets will be taking off or landing. However, California Air National Guard does respond to emergencies. Because the productivity mission is a 90-minute long flying time, it is possible that you might be asked to, at your next landing, pause, and just keep that in mind. It is not going to affect the vast majority of you, but just keep that in mind. If you have a system that is thermally limited, you might be saying, sweet, I got lucky, I get to let it cool down for 10 minutes. Some of you might say, oh shoot, this is gonna be maybe 10 minutes, might be 30 minutes that I have to pause here. Is it worthwhile shutting down my engine? That'll be a little element of randomness there, but just keep that in mind that it's a possibility. Very unlikely, but it's a possibility. Because this is also a 90-minute flight attempt, you need to block out a couple hours per team. If you do the math on how many teams we expect and how many days, we're gonna be doing our best to be running more than one productivity course on the airfield at once in parallel. As well as if we have a lot of teams, then we might have to stretch that to multiple days, right? If it's nominally a Friday-Saturday event or Saturday-Sunday event, we might be doing more productivity mission flying earlier in the week without audiences. So GCS, Ground Control Station. For each of these missions, we're gonna have an area where the ground control station is meant to be set up, saying, hey, go set it up over there inside this box. It will likely be a beam, the operation zone, so somewhere, kind of here in an area where it'll be easy to communicate with the payload handlers. And then finally, a big part of this productivity mission is assessing your system weight. And so the system will be weighed on the truck or on the trailer on the way to the mission. and then also after, but with the GCS on board, because we are not including the GCS weight as part of the system. So there's a little bit of a logistical complication there for after you're done with your system, load up your GCS and get that weighed, then you can load up your aircraft. For the adversity mission, this is intentionally it's intentionally vague in the rules on what the specific layout will be. That's why we have that marker in the middle, such that you can still plan your mission, assuming there will be a certain amount of flying from one to another. But that allows us to, in whatever space we have, to put some of these OZs close to each other. So it could be a fan configuration, a ring, a bow tie, whatever it may be. And then again, the GCS will likely be close to the base. So right in here, the base is kind of depicted as, if I can get a cursor over here, as kind of this rectangle here. So think of that as where you're deploying your system. It's going to be relatively close by of where you're going to be asked to set up your GCS. So for the maneuvering mission, there are multiple possible GCS locations. It could be close to the base. It could be somewhere kind of middle of the course. One of the elements here is we are still going to do our best to diminish GNSS signals at the spot landing zone. It will likely be by trying to stack ISO containers, steel shipping containers, to both block signals and create multipath, which means that's going to create approach angles. It's not going to be just posts going in and out of there. It also means that if we are able to mostly surround it, we're still going to let you have line of sight from wherever your GCS is set up to that spot. So that would be, you can imagine if we're doing that, setting up a GCS kind of here, a beam of obstacle 3, such that you can still see inside that gate while you're, even though your GPS antenna can't see the sky very well. That's most of what I want to cover. I'm trying to mostly just prompt questions because I can't predict what the questions are in your mind ahead of time. So if there are any other questions, I was glad that some of you interrupted me in the middle for those, but yeah, Rob.
On the tornado,
Mm-hmm.
is that going to be variable winds and variable directions, or is it a steady high wind from one direction?
So the plan for that, what we'd like to do, not necessarily. Oh, sorry. Yeah, the question wasn't Mike. The question is the tornado OZ for the adversity mission going to be steady winds or unsteady winds, one direction, multiple directions? What we're going to try to do is get artificial wind machines, whatever we can source, and we're going to try to get them pointing in different directions at different levels if we can. So that's the intent is for it to be, but we don't plan on necessarily throttling them randomly. So the intent is to have them running constantly, but not all pointing the same direction or at the same height or angle. Everybody, so the goal here between my talk and what Kevin's going to talk about next is to try to get you a good idea, help you start visualizing what this weekend is going to look like of the competition and what to expect, both to help you plan and build your system, but also just the logistics. Speaking of the logistics, if you all don't know Kevin O'Grady, he is, you will. If you go to this event, you will, because Kevin is essentially the event producer, and he is the one who is going to really make it happen. So I'll pass it over to Kevin. If you want, you can even start talking before I get this presentation up.
No, that's fine. No rush. Nice to meet everybody. Thank